Welcome students. In this lesson we will be looking at the factors theorem. Before we start this lesson, let's understand the pre-knowledge of the factors that you learned from the junior college. In order to find the factors of 4, you need to have an understanding of the two numbers multiplied together. 1 times 4 gives you 4 and 2 times 2 also gives you 4, which means the factors of 4 is 1, 2 and 4. Similar to that, to find the factors of 6, we know that 1, 2, 3 and 6 are factors. 2 times 3 gives you 6 and 1 times 6 also gives you 6. I want you to have a clear understanding that when you multiply the two numbers, it gives you product. And in this example, 3 times 2 is a factors of 6. A quick recap on the remainder theorem we learned from the previous lesson. In order to find any remainder for the given polynomial, we can either use the direct substitution or synthetic substitution, and then we can figure out the remainder. Factor theorem is similar to that, but the only difference is the binomial x minus a is a factor of the polynomial f of x if and only f of a is equals to 0, which means when you divide a polynomial by a binomial, you have to end up with the remainder 0. Let's see in this example, for the given polynomial x cubed plus 5x squared minus 12x minus 36, when it is divided by x minus 3, then you will end up getting 0 because x minus 3 is a factor. So, since the remainder is 0, x minus 3 is a factor of the polynomial. Let's look at this example. The question says, is x minus 2 a factor of x to the power of 4 minus x to the power of 3 plus 2x minus 2? So, which means we have to divide this polynomial by f of x, which is f of 2, either in the substitution or synthetic method. You will get the remainder as 10, which means x minus 2 is not a factor for this given polynomial. Remember, in order to be factor, the remainder must be equivalent to 0. In another example, show that x plus 2 is a factor of the given polynomial. So they are asking show or prove something like that. So we know that f of x is minus 2. So if we substitute that in the given polynomial, we should end up getting 0. If it is equivalent to 0, then we can confirm x plus 2 is a factor of the given polynomial. And let's see in this example, given that x minus 3 is a factor of f of x, which is 3x cubed minus 2x squared minus kx minus 6, find the value of k. Here they are introducing an unknown variable as k, and they want us to find the value of k. Let's see what are the given information. The given information is x minus 3 is a factor. So we know that if it is a factor, the remainder must be equivalent to 0. So you can comfortably make this equation to 0 and replace x with 3 and solve for the equation and find the value of k, which is k equals to 19. And in this question, find the value for k when this function, polynomial function, is divided by x plus k, and this time they put an unknown variable in the divisor. The previous problem, it was in dividend. In this one, it is in divisor. And also they have given additional information as a remainder of 8, which means the function can be equivalent to 8. And when you substitute x as minus k, because it's plus k, you have to substitute as minus k, you will end up getting a quadratic equation as k squared plus 3k minus 18 is equals to 0. And if you solve for it, you will end up getting k equals to minus 6 and k equals to 3. And let's look at this example. Given a polynomial function 3x cubed minus 5x squared minus 58x plus 40, and one of its factors as x minus 5, find the remaining factors of the polynomial. And remember, sometimes the factors may not be binomial. So in this case, one of the factors is x minus 5. So the rest would be an quadratic one. When you multiply x minus 5 with the quadratic equation, you will end up getting a cubic equation. So in order to find the value of a and c, you have to look back at the equation. Let's see, the constant is 40, and we have one of the factors as x minus 5. So in order to reach 40, minus 5 times minus 8 gives you 40. That means C value is minus 8. Let's see in x cubed. X times x squared will give you x cubed. That means A is 3. Straight away we can figure out. In this case, we figured out A as 3 and C as minus 8 by looking back at the constant and the coefficients of x cubed. Now the final thing, we have to find the value of b. In order to find the value of b, we can compare the x squared or x term. So first I'll show you how to compare the x squared term. So when you compare minus 5 times 3x squared and x times bx squared, you will end up getting minus 15x squared and plus bx squared, which is equivalent to, going back to the equation, you can see that is equivalent to minus 5x squared. So collect the like terms and equal the value of b, which is equal to b equals to 10. Once you figure out the value of b, you can put it back in the quadratic equation and factorize for that particular expression, and you will end up getting x minus 5, 3x minus 2, and x plus 4. As I told you earlier, you can also compare either with x squared term or x term. Let me show you if you compare with x term. So minus 5 is multiplied with bx, which is minus 5bx, and x has to be multiplied with minus 8, which will be minus 8x. is equivalent to minus 58x from the given equation. When you collect like terms and solve for it, you will get b equals to 10. So you can plug in the value of b, a, and c. Remember, finding the value of a and c is pretty easy by looking at the constant and looking at the coefficients of x cubed. In order to find the value of b, you can either compare x squared or you can compare x, and then you can find the remaining factors. There is another way to figure out this by doing a long division. You can divide this big polynomial by the divisor of x minus 5, and also you will end up getting this expression. So now you can try these questions. Given a polynomial and one of these factors, find the remaining factors of the polynomial. So for this polynomial, the given factor is x minus 7. So you give it a go and try and find out the remaining factors. So pause the video and try and find. You can go back and take notes from the previous examples and figure out. That's all for this lesson.